The broadcast is now starting. All attendees are in listen-only mode.
Well, good afternoon, everybody, and welcome along to DBA Fundamentals for the month of May. We are a couple of minutes late. I was experiencing some issues with my audio. My name is Warwick Rudd, and I'll be your host again this month. And for this month's session, we've got Greg Lowe, who's going to take us through understanding character data types in SQL Server, including UTF-8. Before I hand over to Greg, I do have a couple of slides that I do need to run through, just as our normal housekeeping. So first off, big thank you to our sponsors, SentryOne. Without our sponsors, it makes it difficult for us to put on these sessions for you. If you haven't already visited SentryOne's website, make sure you do. They have some fantastic material there that can assist you in your data platform learnings. As well as SentryOne, our other second sponsor, DBWatch, Database Control. Between the two of them, they provide us a broad range of tooling that are able to assist us from our data platform side of things that we all look after. So make sure you go to DBWatch and have a look at what they've got for you on their free downloads and trials. Just like this virtual group, there are many other virtual groups available for you to register so that you can continue your learning experience. These are available on the PASS website. All you need to do is register, just like for this virtual group, and you can hear about what sessions are being run for each of those. I do have one other announcement. So with us being in the environment that we are in, you may have heard that a lot of SQL Saturdays aren't running in-person events. Brisbane, likewise, we've been impacted and we are running virtual. So we are online and we are going on May 30. So what will you get? You'll get 28 sessions on the day from a number of speakers, both locally, interstate, and internationally. We'll hopefully be posting that schedule in the next couple of days. Registrations are open. You can see the link on your slide right now. So make sure that you register so that you can take advantage of all of those sessions that we are going to be putting on Saturday, May 30. Just as a last piece of housekeeping, this session is being recorded and will be available on the DBA Fundamentals archive site in a couple of days' time. I will be monitoring the chat window, so if you do have any questions for Greg at any time during the session, feel free to ask, and I'll moderate those and let Greg know. So with that, let's get the ball rolling with Greg, and we'll make Greg the presenter.
We can see the screen?
We can.
Awesome. Thanks, folks. Thanks for coming along today and spending the time with us. This session, basically looking at character data. So where I fit in, for those that don't know me, I basically work with the product forever, really, so since it started, and spend a lot of time just seeing what works well and what doesn't in different parts of SQL Server over the years. And it's interesting that with character data types, I find that they're often quite misunderstood, actually. And so I wanted to have a session where we cover that off. Mostly what I'll be showing you this time is demos, actually. So a few slides here and there just to make things a bit more concrete, but overly mostly demos. But the other thing is that this is a fundamentals level discussion. Warwick's got SQL Saturday Brisbane coming up shortly. And in that one, we'll actually have quite an in-depth discussion of how a lot of this stuff works. But for the fundamentals one, let's just see how we travel. So first up, in SQL Server, if you just look at the character data types, these are the ones that appear. Now, in other database engines, things like Postgres and so on, they have just a straight string data type. Very similar to what you have in things like .NET and so on. There's basically a string. A lot of these ones that are here in SQL Server tend to be they're historical, the reasons why a lot of these are like they are, but there's also changes that have happened in these in recent times. The first two that I'd call out are text and end text, and so those ones are old ones that came from Sybase, and they've been around a long time, but they suggest you shouldn't use those anymore anyway. So if you have something that's text, that actually you should be using varchar max now instead. And if you have something that was in text, you should be using nvarchar max. But the other ones, let's just have a look at how they actually work. So I'll just open up a query window here. Now, so if I declare, let's say a value as, let's start with char. So if I said, look, this is char. In fact, if I just said char and then said, look, I'm going to set a value into that, so hello, and then said, look, let's select that back. So notice the first thing is that a char is actually a char 1, right? So if you don't put a size in there, you only get a character. But the other thing I want you to notice is that it's silently truncated the value as it went in. So it's not like a database field where if you try and push something too big in there, it'll blow up with a string or binary value and be truncated. This will just silently truncate the value. So that's the first thing you need to be careful of when you have variables. But if I said, look, this is char 10, and I have a value in here, note that this works as expected, but the thing that's not obvious there is just what's actually returned. So if I put something else here, and let's add a pointer at both ends. So notice that what's been returned is not just hello, but it's hello and then another 5 spaces. So what it's going to do is return 10 characters every time, even if what you're storing in there is only 5 characters. So that's the first characteristic of char. The comparison, if we said, look, I want to use varchar, and that's why it exists, is that it only then returns the characters that you put in. Now, clearly, storing things as varchar, it's got to put a little pointer at the beginning of it that says how big the string is. So it adds a little bit to the storage of it. So you'll find a lot of people wouldn't use, say, varchar 1 because they know that's going to be bigger than just a char 1. I'm not religious about that. I'd actually still be quite okay with it being a varchar. I tend not to use char in almost any situation. But regardless, so the difference between char and varchar is just going to be what the value that gets returned. Now, the thing to understand, though, is what can go inside that string, right? So can we have our normal alphabet? Can we have European characters with accents and graphs and so on? The deal here, way back since the beginning of SQL Server, is these things here are basically single byte characters. So what that means is if we drag in, let me grab ASCIItable.com. Let's have a look at that. So these are the values. So with 1 byte, you've got 256 different values. So the bottom 128 of those values are well defined. And so they go here from decimal. So we've basically got from 0 up to 31, and then the next set, and so on until we get to 127 where a delete character lives. Now the general structure of these, note the first 32 of these are all control characters. So they have things like carriage returns, line feeds, and so on. Those sort of things are in here, tab, and so on. They're the non-visible type stuff. The next set in here are all punctuation, numerics, some symbols like less than, greater than, and so on. Then we have the alphabet, and note that the uppercase alphabet is there, but it's exactly 32 across to the same value where it's a lowercase. So that actually makes it really easy with our characters to be able to convert from uppercase to lowercase and so on. So standard characters are easy to move. But notice what this doesn't give you is any other sort of characters. Now, back when they first did this stuff, in many cases, some people only had 7 bits in a character. So if you had old things like VAX systems, they used to use 36 bits in a computer word. They had 5 7-bit characters and a parity bit. So there was no upper half of the byte. It was more the microprocessors, when they appeared, started using entire bytes for characters. So then the question is, okay, well, we know what from 0 to 127 is, but what's 128 and what's 174? Now, the trick with these is that when they were first introduced, there were no standards for this at all. And so what would happen is that people did not use those characters. And that's why, even if you think about a keyboard, it's a pain in the neck to try and put one of those characters in. You've got to hold Alt down and then type the number that you want, like 174. And then that'll give you the character on the screen. But a big part of the reason why people didn't do this is that there were different standards. So for example, I might have a screen and I might type a character, whatever 174 is, and maybe that's an A with an accent. But then when I printed it out on a printer, it would have a different set of characters for those upper characters. And so what would happen is I'd get a different thing coming out in the printer than what I saw on the screen. So people went, this is just useless. And so it wasn't that there weren't standards, there were just a whole bunch of them. So that was actually a really, really bad thing. Now, when they implemented DOS, they actually added a whole lot of those standards in there, and that's what a code page is. So a lot of people see the word code page, but don't know what that is. What it is it's a definition of what's in the upper half of the byte, rather than the lower half of the byte. Now, there's a standard one here. Nowadays, and this became pretty much the standard, was the PC one. And so notice what it's got in here is it's got accent over A's and E's and things like this. It's got some line drawing characters and so on, because it was very common in a text-based system to want to draw boxes around things and so on. So you had these sorts of characters living inside this. But as I said, this is for a particular code page. And so you'll find whenever you're working with SQL Server and it asks about bytes, it wants to know about code page. We'll look at collations later. When you specify a collation, it has a code page. And so that says when you're working with these types of things, how do I know what 174 is, or how do I know what 169 is? It's by the code page. And same if you use SQL Server integration services. You'll find whenever you define strings, it wants to know not only how long is the string, but what code page. And so that's what that is. Now, if you look at these though, even for someone who speaks the European language, having the A's and things all tucked up here, rather than back down with the A's and so on, makes it a pain in the neck for sorting and so on. And so, for example, more A's here, A up here, and so on. This is not a good thing. So in most languages, what you really want is you want a grouping of the characters that relates to the language itself. So you don't really want to just be able to store all the characters. You want to be able to have characters in the correct groupings. And so that's a problem when you only had from 0 to 255 to work with. Now, that's fine. And if we look here inside SQL Server, so we can put any of those characters in here, and that'll be fine. So for example, I could grab an A with an accent and something. That'll be absolutely fine inside here. But the problem is, what about other languages? Because we saw that little list of characters and they only have a couple of hundred characters. But the question is, how many different characters do you need to be able to store characters from every language? And they had a project back in the 1980s where they looked at that, and the answer was 3 bytes. So you actually needed 3 bytes to store any character from any language. Now, at the time, we had 2-byte or 16-bit computers were the most common. So no one wanted to hear an answer that said, let's stick characters in 3 bytes. Because all of a sudden you're saying a character wouldn't fit inside the register of a computer, or common computers at the time. That was not something people wanted. So what was introduced is a thing called Unicode, and it had a character set defined. So you want to think of Unicode as a character set, and what it had is it had all the different sort of characters that were required. But the initial set of those that they worked with was a compromise. And what it did is it gave us 2-byte characters. And so we had from 0 to 65535 as the values we could use. Now, the challenge with that is that's nowhere near big enough. So, for example, if you look at Chinese or Japanese, Chinese is a good example. Scholars would tell you there are somewhere around about 30,000 characters in Chinese, right? So up around that. Now, a normal person doesn't use those. They use about 2,500 to maybe 5,000 of those on a daily basis, depending upon level of education and so on. But there are that many characters. So if you have a language like Chinese that has that, and then you have a language like Japanese that adopt or had most of those Chinese characters, but it also had different character sets. So they had hiragana, which is a set of sounds for all the different sounds. They had katakana, a set of characters for words that have come from another language. Like we just adopt a French word, we put it straight into English. Sometimes we might write it, but they had a completely separate character set for words that have come from another language. So to be like if we had A to Z, and then we had characters that we used for French or Italian or whatever words. And then in addition to that, they had the kanji characters, which are then the ones that have come from Chinese. So the thing to understand is that if you started with 30,000 odd for Chinese and probably had close to another 30,000 just for Japanese, then all of a sudden you were talking about all of the characters were gone, very close to, before you even had any other language. So this is a compromise when we sort of squash it into 2 bytes. But the support for that in SQL Server was with nvarchar and nvarchar. So nchar is just a fixed length one again, same as we had with char. And nvarchar was the one where we were basically allowing double byte characters to go in there. Now, they call them byte pairs. We'll come to that a bit more in a minute. But the idea is that there were sort of 2 bytes each time. Now, one of the things that you may also have never thought about is that if you've got 30,000 characters in your language, how do you type that on a keyboard? Right? So that's far from obvious to us if we're used to only working with, a few dozen values on a keyboard. And so this is where input editors come in. So if I'm working with a Windows computer, I can tell it, this little English down the bottom here, I can add additional languages in there. So I've got English Australia and English US as keyboards, but I've also got, say, a Chinese pinyin in here. Now, I could add Japanese in there, I could add other ones in there, and they work just fine. But there's a challenge with using those. It's very different to doing it when we work with English. And the way we do that, I can pick it directly over here, or I can hold the Windows key down and hit space, and then it cycles through the different ones. Now, once I get into that mode, I can then type in here. So, the first thing a lot of people learn in Chinese is like how to type. Actually, let's just start with this. And so this is NI, this is a word for you. And notice that as I type that, it's then got a whole lot of characters here. Now, the thing to understand is that every single one of those is NI, right? So what's happening here is it's giving me a list of these, and with many of the characters, there are way, way more of those. And so, but what I can do is go recognize the one I want, and then hit a 1, and it pops that straight in there. And similarly, people usually learn this for hello, although hardly any Chinese person I know actually says that. But anyway, so ni and then how. And again, I could pick how there and hit a 1, and that'll pop that in as a phrase inside there. But the other thing is that rather than picking all the characters one at a time, the input editors make it easier. So for example, if I went NI and then went HAO, what it's showing me is pairs of characters that normally go together that are those characters. And so if I then hit a 1, I get both characters. So this is actually a very fast way of being able to type this, but it requires me to know the NI and the HAO and so on. And so with that, that's actually what's called pinyin is the thing. And so now if I put that in here and I execute this, notice I don't get anything back. And so what I get is a couple of question marks. So it didn't understand what's going on here. Now, this is the way they've set the character setup so that what you'll find is that this is what it gets mapped to if it doesn't get what's going on. Now, what's missing in this, you might stop and think, well, what's going on here? The thing that's missing is the N in front of here. Sorry, I should put that in my English keyboard. So if I put that there, notice it then works, right? So you may have seen in lots and lots of bits of SQL code and things like that, you see this sort of N sitting in front of character strings. And you may have wondered, what on earth is that N there for? And for most people, it appears to work regardless. So for example, if I had put hello in here, so notice that works. But if I'd left the N out, it still works fine, right? But that's because I'm using characters that can work like that. And if I go back to this, so if I, in here, and as I said, this isn't going to work, but if I put an N in front of here, it's going to work. So where this is going wrong, if I don't have the N, is that when I have a string like this, surrounded by single quotes, what it does with that is it assumes these are single byte values. And so it'll translate it to a single byte, even though I put double byte characters in. And then even though I'm assigning it to the right sort of location, the damage is already done. And it's the same thing if I had pushed these into a varchar, I'd get exactly the same problem because I'm not storing it in somewhere that's appropriate. Now, one of the things you may wonder about is, okay, well, if I said, what's the length of that string? Because I said these are 2 bytes each character. And so notice the length of that is 2. So it's looked at the number of characters, not the number of bytes. And so there is a function there for that. So data length will then tell you this is 4 bytes long. And so we can use that. Now, that's been the basic difference with these for quite a while. And so if we go back and look at here, in our set of values here, so char we said was fixed length, come to the UTF-8 in a minute, nchar, which was then a fixed length one that can do double byte characters or Unicode, varchar, which was variable length single byte, and nvarchar, which is variable length Unicode. The other two here, varchar max and nvarchar max, are the large value, the blob versions of these varchar and nvarchar. There's a subtle thing to understand is that they're actually a different data type under the covers, but for the moment, you could just think of them as very, very long values. So the limits we had before were that varchar could be up to 8,000 characters, or 8,000 bytes, we'll discuss that in a minute, and nvarchar could be up to 4,000 byte pairs or double byte characters long. These ones, varchar max and nvarchar max, can be up to 2 gigabytes of data. And so they can handle really, really substantial size things. Now, next concept to understand is collations. And so people often get confused about what a collation is. And so a collation is a set of rules that determine how sorting and comparisons work. So they determine whether case matters. So like, does a capital C match to a lowercase c or not? They work out whether or not accents matter. So is an A with an accent the same as an A without an accent or not? So that's the case sensitivity stuff. The other thing they do is they determine the code page that is going to be used if it's not Unicode data. So we said before, code page was the set of values for the upper half of the byte. Now, if you look at the example down below, I've got select from some product where the product name is like %corn, but I can also specify the collation to be used for that comparison. And so in this case, I've said SQL Latin 1 General, CP1, CSAS. Now, first thing with collations is that all the ones that start with SQL are old Sybase collations, and the advice for a long time has been to avoid using them. The thing that's painful about that is that in an awful lot of places in the world, SQL Server, when you install it, defaults to that. But if you look at the collations that don't start with SQL underscore, they are the Windows collations, and they match the ones in your Windows operating system. All right. So Latin 1 General is the character set. It's actually very similar to Latin 1 General 100, which is another one you'll commonly see. And when we built the wide world importers, you'll find that that was the default character set for that. The next thing here is the code page. Now, this is actually code page 1252, and you look and go, why on earth does it say 1? There's a quirk, historical quirk, where code page, that is code page 1 as well. And so anyway, it's the default one that's the code page. Then we've got CS or CI, so case sensitive or case insensitive, and then accent sensitive or accent insensitive. There are others that can go on there. You can have Kana sensitivity, you can have width sensitivity, and so on. So, but that's what collations are. Now, you can set them at the server level. You can set a collation at the database level. You can't do it at the table level, but you can do it at the column level. So you can have two columns, even in a single table, that are defined with a different collation. And of course, the only time that becomes a problem is if you say, is this column equal to that column? Or is this column less than that column? And so on. For most people, the number one place that they come unstuck with this is when you have temporary tables. Right? Now, the deal here is that if I say create table, hash something, and then go on and define the table, the question is what collation, so some name, and I'll say varchar 20 or something. The question is what collation is that using? And the answer is it's the collation of tempdb. And so by default, and something you probably shouldn't change, that's the collation of the server as well. So where people often come unstuck is they then create a database that has a different collation to the server, and all is well right up until they create a temporary table, and then they try and join the data in that to a table that's inside their existing database. Then you'll get one of the things that tells you it's unable to resolve a collation conflict and so on. So the deal there is that if you are using tempdb, every single time you have a thing that says where, you know, col in something is equal to the temp other col or whatever, you need to say collate and then put a collation to say this is the one that'll be used for the comparison. Because if you don't do that, otherwise your application will only run if it's on a server that has the same collation as your database. And you don't want to do that. Now, the easy way to avoid hard coding the collation is you can say database default, and that says just use whatever the one is for the database. So if you allow the user to create their own collation or assign it to the database, and you want to be able to use temporary tables and things, every time you have a where clause that compares or an on clause, or you're saying greater than or equal and so on, you need to whack collate database default, or the other time you might do that is if you want to use a specific collation. So in the example that was on the slide a minute ago, it was saying regardless of the database collation, when I do this comparison, I want it to be, you know, case sensitive instead. And so you can choose a collation to do that. So that's the idea of the collations. Now, to get an idea of the ones that are there, do a select from sysfn help collations, you'll find there are a large number of collations that SQL Server supports out of the box. There's a big list of these, right? In fact, this one here, 5,508 different collations. So that's a powerful set of collations in terms of what it does. Now, there are a few collations that are specific and important. And so one of them, so if we said where name like SC, oh, then notice there's a whole bunch of these that have SC on the end. And so what that's about is if you scroll over here, it says supplementary characters. Now, for a long time, what we had is just what I was sort of showing you before. Let me pop this, see if I can go right back far enough. Does it work far enough back? Ah, there we go, that'll do. So what we had is supplementary characters. Now, I said before that these were 2-byte characters. But in SQL Server 2012, this changed. Because what it meant is that there were also supplementary characters that were 4-byte characters. So what I could have had in here is a 2-byte character and a 4-byte character if you used supplementary characters. Now, it does not allow you to use those collations at the server level or the database level, but they can be used at the column level within a database. And so that allows you to put additional things in. So you might wonder, like, what on earth are these supplementary characters? Well, what they've done is that they've expanded Unicode so that they can store all sorts of things that they couldn't store before. I said that Unicode was a compromise where it was the previous stuff we had for ASCII, they were single byte things and we were using 1 byte at a time. Unicode is actually an encoding, it's a character set, not an encoding. So Unicode has a very, very big number of characters defined, but it had different ways of encoding them. And what we had in SQL Server previously was a 2-byte one, UCSC, I think it was called, UCSC, and so on, or UTF-8, was another thing that it used to be called. But they're very similar. But the thing with that anyway is that they were 2 bytes at a time. But Unicode itself defined a whole lot of additional characters. So there are also allowed 4-byte encodings of the Unicode characters. Now, this allows you to get way more characters than what we could have used before. Now, the thing gets bigger, and that's where data length and length become such an issue. But the idea here is it starts to fix the problem that we had with Unicode, where you could only have 2 bytes. And so there were, as I said, it was a big compromise that was made. And so what they talk about in Unicode is they talk about planes. And so Unicode has what's called a multilingual plane, and that's that first lot of 2 bytes. So really the first, 0 to 65535. What they then have is a supplementary multilingual plane, and that's the next 65536 values. And that's the one that goes and fixes the problems that we had with the previous languages. Then there's an ideographic plane, and this is the next 65536. And of course, the idea is that because we have 4 bytes potentially, in fact, we could have 65,536 different planes, each of 65,536 characters. Now, we don't need that, right? But they also have things like private use planes and so on. But the thing that's interesting with this is we're going to start to see characters appearing in computer systems that we've never seen before. So, for example, things like musical notes, can suddenly become characters that'll get stored inside a computer system. And of course, they want to be able to deal not just with all the current languages, they want to be able to store all the ancient languages. So, everything from hieroglyphics onwards, every one of these things they want to be able to store and use inside a computer system. Now, the problem that this has caused over the years is that if you look at the 2-byte characters and Unicode, people used to look at this and go, I don't need those other characters, so they'd make the database just be varchar. And they go, so I don't want to lose or use twice the space to store things. And so that was, look, in many cases, that was a fairly valid concern back in the day. Now, one of the things that you should know about, though, is that in SQL Server 2008, R2 and later, they implemented Unicode compression, or what's called Unicode standard compression, in the database engine. And so the penalty you are paying is nothing like what it used to be. And in particular, if you're using row or page compression at the table level, and if you look at a row compressed page, you'll find that your characters that were nvarchar, if they're just ASCII characters, they just look like ASCII characters again. They're not padded out and stored as 2 bytes. Now, I think in 2008, table compression was the best thing in the product. If you're not using it, you're missing out. In particular, I think row compression should be the default for all databases and all tables. Page compression makes sense in certain situations. But if you're at least using row compression, then you're not paying the penalty for storing nvarchar values in your database instead of varchar. Now, the other thing that was a concern is that, okay, well, if I wanted instead, could I use a 4-byte format all the time? They could have just decided to do that inside the product instead of having things where it can be either. And of course, the size of that started to be, a real concern for a lot of people. So this is where another thing appeared called UTF-8. And so what UTF-8 is an encoding of Unicode data that is a variable width encoding. So some characters are 1 byte long, some characters are 2, some are 3, some are 4. And so this is, as I said, it's not the character set, which is what a lot of people get confused by. That's still Unicode. But what it is it's a way of encoding Unicode for storage. Now, what they did is they designed it to be compatible with ASCII. So the bottom 128 characters are exactly the same, and they are unchanged. So the nice thing with UTF-8 is if all you are using is ASCII characters, then they take exactly the same space as they used to take. They use the top bit that's then used for the upper half of the byte to indicate the other options. And so they use the least number of characters, basically, that they can get away with. And this is super, super common in websites and things. It's become the most common encoding nowadays for websites and so on. Now, there's been a push in SQL Server to have this in place for many years. Products like Postgres and so on, I mentioned earlier, their string data type has been UTF for a long time. Right, so this is a very, very common thing in the industry. Now, what I want to show you with UTF-8 though, is it changes a bit how things work. And so let me grab this one here. So I'm saying, look, drop the table if it exists. I'm creating a table, but notice I'm putting UTF-8 on the end. And so that's another collation. So if we say sys fn help collations, where name like percent UTF-8. Have a look. Oh, sorry. Keep forgetting that one's a table valued function. And so notice there's a whole bunch of these. In fact, 1,553 of them that are now UTF-8 collations inside SQL Server. All right. So I've just picked one of those to use. And what I want to show you here, so this is adding it to a column in the database, but notice that I've defined this as a varchar, not as an nvarchar. And so this is what's interesting with this, is because it's stored in locations that are ASCII size stuff in general, what we're talking about is it doesn't need the double byte. It doesn't need the byte pairs. It just encodes it within the same single byte type storage. And so notice here, I've then said, look, insert into that. I've put hello there, and I've put that with an N there. So the question is, what happens, you know? And given the fact, now, if I left the collate out, we saw before that what would happen is that wouldn't work in either situation, because this one here would have converted it to a single byte set of characters. The truncation would have already happened, and that's what it would have been put in here. In this case, it would have taken a double byte set of values, and it would have put it in here where it would have got truncated anyway. But notice the difference here is that if I leave the collate out, if I put the collate for UTF-8 in, then notice this one now works. And so the idea is I still have to define in SQL Server my string as a multi-byte string, but I can store it in a varchar column where I've defined the collation as a UTF-8 collation, and it works as expected. All right. And so look, final thing, just say thank you for listening. We're coming up towards the end. And if you want to get in touch with me, just greg@sqldownunder.com. One of the things I'll just quickly show you too, at our site, at sqldownunder.com, there's a whole bunch of free stuff down here. So look, pop over and have a look at that. And look, there probably are things that are of interest. For SQL Server people, our tooling is worth a look. The podcast is interviews with people I think are interesting in some way in the SQL Server community. There's a bunch of free ebooks. There's file split utility and a link to the blog and so on, a bunch of podcasts. But look, pop there because there are things we're adding all the time that you'll probably find useful. And so, but as I said, if you want to get in touch, pop and see me there. If you want to learn things, we have training.sqldownunder.com. So that's where I'll get to today. So Warwick, are there anything that's questions at this stage? Yep, no Warwick.
Yes. Okay, bear with me a second. Okay. Can you hear me, Greg?
No problem.
Okay, so we've got no questions from the audience at this point in time. However, on that last slide that you were working through, would it be your recommendation that from a certain version of SQL Server to use the special character and UTF collations more as the default?
Yeah, look, there are things where I would like that to be the default. There's actually a thing that actually raises that I should have mentioned, is that there's one major hesitation I have with this at the moment, is that, see, when I write varchar 50 like that, most people would assume that that means up to 50 characters, right? And same if I had said, you know, declare a variable as, you know, varchar 10, people think that means up to 10 characters. Now, the SQL Server team goes, no, 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 no. That actually meant 10 bytes, right? And so they said it's never meant 10 characters. And you go, okay. Now, in other languages, like I mentioned Postgres before, that means 10 characters, no matter what they are. In SQL Server, this actually means 10 bytes. And so if I have this as a Unicode collation in a table, if that was varchar 10, that means the column would fit somewhere between 2 and 4 bytes. 2 and 4 characters. Because there might be 2 single byte, 2 byte, 3 byte, or 4 byte. You actually don't know how many characters will fit in there. Now, I look at that and go, oh, you know, to me, that's deeply troubling, right? Because to me, the reason I want to put a number in brackets there is I actually want to limit the number of characters. And similarly, what they say is and then they have a different rule that says if this was nvarchar 10, that's 10 byte pairs. So that actually means 20 bytes. And then it depends upon the characters that you shove in there, how many fit. Now, I look at that and go, from a developer's point of view, I couldn't care less what all the characters are. I actually just want to limit the number that fit. Yep. And so I've got, there's a user voice request that I've got that I've said, look, you know, when you say varchar 10, that really ought to mean 10 characters. Right. And for that reason, I'm not at all happy with how they've implemented UTF-8. Does that make sense?
It does. So, because that would make it very confusing for developers and people using to work out just how much data can you put in that particular column or value, which would just add a whole lot more work.
And see, because the question is, why would you put a number here at all if it's just bytes, right? See, so one of the arguments is, the way I could define a column is I could say, always just say max, which makes people shudder. But then the question is, how do you restrict it then to a certain size? And so what I would then have to do, you know, is constraint blah, check, you know, that the length of data value, you know, is less than or equal to 50. You know, is that what you really want to do on every column? And then the worst thing is that length doesn't work properly either, right? So with characters, if I say, what's the length of hello and a bunch of spaces, the length is 5. So it ignores trailing spaces. Now, again, I actually think that's broken, the way that's implemented. So what it means here is that you have to get the data value, and then you'd have to add something onto the end of it, and then do something like that to make a constraint that actually worked properly for 50 characters. And am I comfortable with that? Not in the slightest.
It's a very ugly Band-Aid.
And so this is why I've been like pushing and pushing and pushing on them to say this doesn't make sense. You need to change it. So the problem with SQL Server is that by the time things are shipped, you know it isn't going to change, right? Because backwards compatibility, it's going to have to be like that for the next, 18 years, or so. What we have asked them to be able to do instead is to be able to perhaps put a different thing in here where we could say 50 characters. Yep, something like that. I could live with that. But yeah, the idea, and they keep saying, oh yeah, it's always meant bytes, but to me that the issue is not what it's always meant, and because in the end it didn't matter before. To me, it's what is actually useful to a developer. So there you go. So anyway, so you might have thought characters are simple, not so simple.
Well, thank you very much, Greg. Thank you, everybody, for turning up today and being part of this month's session. At the start of the session, I did mention about the SQL Saturday Brisbane event. There are about 2.5 weeks to go until we will be hosting that event. So if you would like to participate in that virtual event, please feel free to register at the SQL Saturday website, and then you'll be able to get the online links to be able to join the sessions throughout the day. Thank you all for coming along. Stay safe. We'll see you all again in a month's time.
Thanks, folks.